f of x equals 2x squared plus 5 to the 7th, then f prime of x equals.
So what rule are we using on this one? Chain. And just to recall chain, we take the power and do what? Bring it to the front. And do I do anything with the inside? No. So we have 2x squared plus 5. And what happens to my new power? Subtract 1. And then because it's chain rule, what do I now need to do? Derive the inside. What is my derivative of the inside? 4x. And what would match that? D. If you had it and your neighbor had it, give them a high five. You say, good job. You got number 1. Out of how many? Like 45? Somebody give Holland a high five, please. There you go. All right, number 2. I'm on number 2. Bailey, let's read.
What is the integral of 1 over 3x plus 12?
Okay. So looking at the bottom, is there a common factor I could take out to make this problem easier?
Yeah.
What's my GCF that I could take out? Do we see 3 on the bottom?
Yeah.
So could I call that 1/3? So if I were to write this and kick off the 1/3, it's going to look like the following. 1/3 integral, 1 over, the boys are not listening, x plus 4 dx. And then we have to use our u substitution. So if u is equal to x plus 4, what is du? dx. Do I already have that dx? So when I do my direct substitution, I'm going to get 1/3 integral of 1 over u du. Now, at this point, you should be very comfortable with the integral of 1 over u. What is that? Natural log of what specifically? Absolute value. 1/3 natural log of the absolute value of u. And we always need plus what at the end? When do we not need c? If it's a bounded value. Very good. And then let's plug the u back in. So we have 1/3 natural log of, and our u value was x plus 4 plus c, and that's going to give us which answer? B. Again, if you and your neighbor had it, go ahead and give them a high five. And maybe a good job. Holland, question? All right, number 3. Yes, ma'am. Yeah. We're only going to count the ones that you got right. Okay? And the thing is, just because you got more wrong at this point doesn't mean that's going to be your accurate score. Okay? Because right now we're still practicing. Does that make sense? And I know the timer going is very nerve-wracking. All right, number 3. All right, Kira, let's read number 3.
If f of x equals 5 minus x over x to the 3rd plus 2, then f prime of x equals.
And I would put in parentheses. First of all, I just like them, but it kind of helps you look at the group. So what rule are we using on this one? Quotient. And on the quotient, I told you guys, always start with top or the bottom? The bottom, because it is bottom what? Very good. Bottom all squared plus 2. And for the quotient, what operation separated the numerator? Subtraction. So let's start with that. So let's kind of recall the rule. This is like unit 1 or 2. The first thing we do is we derive which part? Top. So what's the derivative of the top? -1. And do I do anything with the bottom? The original bottom stays. X cubed plus 2. And then what do I do after the minus sign? Keep which part? The top. And then we derive the bottom, which is going to be 3x squared. The hardest thing here is doing the algebra and simplifying, because it's not really helpful on the bottom. Look at your answer choices. Not very nice, right? I wish I could eliminate 2, but that's just the reality. So let's only focus on the numerator. So I'm going to circle it so we're not looking at the bottom. Just focus on this guy right here. So let's start by distributing my -1. So we get negative x cubed minus 2. And I'm going to do 2 things in one go on the next one. We're going to distribute the 3x and also the negative at the same time. What's that going to give us? Minus 15x squared. And then when I distribute to my negative x, we get in the other negative, we get plus what? 3x cubed. And then all we need to do is combine like terms. Let's put it in descending order. Combine the cubes first, which is how many? 2x cubed. And then we still have minus 15x squared minus 2. And that's going to be which answer choice? C it is. All right, go ahead and give your neighbor a high five. Say good job. You remember unit 1. All right. Oh, that's not it. So then let's recall Riemann sums from unit 4. Are we ready? All right, Addison, let's read.
What is the approximate distance in miles from travel from t equals 0 to t equals 3?
All right, Kira, let's read again.
The table above gives the velocity v and t in miles per hour of a truck at selected times t in hours. Using a trapezoidal sum with the 3 subintervals indicated by the table, what is the approximate distance in miles the truck traveled from time t equals 0 to t equals 6?
So our keyword is our trapezoidal sum, because we need that formula. How many subintervals? 3, so I need to make 3 loops. So starting from the beginning, 1, 2, 3. And just in case you might have forgotten, maybe I should hide it with something. Okay. So our trapezoidal Riemann sums, it was base 1 plus base 2 divided by 2 times the height, yes? So does it matter which one I let the base 1 be? Because in the end, we're going to add it. So we have 20 plus 60 divided by 2 times the difference of the x's are the height. So what was my difference of the x's? 0.5. Go to my second one and try to ignore my first column there. What's my base 1 and base 2? 60. 40 divided by 2. The height is the difference of the x's, which is 1.5 plus my next one. What's my bases? 40 and 30 divided by 2. And what's the difference of the bases? 1. And I know we have our decimal, it's going to be non-calc, but multiplying by 0.5 shouldn't be a problem. Okay, let's see if we can do this mentally. Y'all ready? What is 20 plus 60?
80.
Okay, 80. 80 divided by 2?
40.
40. Half of 40?
20.
Boom. If you feel like you have to write that number down, go for it, okay? The next one, 60 plus 40?
100.
Good. 100 divided by 2?
50.
50. So if I take 50 and half of that, I get?
75.
Very good. And my last one, that one is kind of irrelevant. 40 plus 30 is how many? 70, half of that?
35.
Boom. And if we were to add this, it's going to give us 130. What's our answer choice?
B.
Boom. Go ahead and give your neighbor a high five. All right, our last one. All right, I'm ready for the last one. Caitlin, let's read number 5.
If f of x equals sine x squared plus pi, then f prime of x equals square root of 2 pi.
Now, I bet you're looking at sine and kind of freaking out a little bit, and then you see square root of 2 pi and go, right? Okay, this is still chain rule. So the very, very outside is my sine. What's my derivative of sine?
Cosine.
Cosine. Do I change the inside? Not yet. Keep it. And then we derive the inside. Keep in mind, pi is not a symbol. Oh, it is a symbol, but it's representing a number, right? So that one is not going to be, it's not going to matter for the derivative. So what's my derivative of the inside then?
2x.
2x. So now all I need to do is, anywhere I see an x, I'm going to plug in 2 pi with a radical. So let's plug it in. We get cosine. The next one is kind of nice because we have square root and a squared. We all know what happens there. And then we have times 2 of radical 2 pi. So when I have a square and a radical, what happens to the inside? It's going to cancel and come out, right? And when it does, what is 2 pi plus pi? So we have cosine of 3 pi. And I'm gonna leave the next one as it is, just because the 2 is inside and outside of the radical. So here's our main focus. This is gonna control our number. So let's do a recall of where 3 pi is. If 1 pi is here, not 1 pi, 0 pi, I'm gonna fail pre-cal. If that's 0 pi, this is 1 pi. What is this back again over here? 0, 1, 2 pi. So that means this over here is going to go back to our coterminal, 3 pi. So go ahead and make your order pair. My order pair here is what comma what? Negative 1 comma 0. And cosine is which value, x or y? The x. So if I were to plug that in, we get negative 2 radical 2 pi. Do we see that? Yes. All right. Go ahead and give your neighbor a high five.